Or would
Yeah.
you have to do this by hand? Okay. So as a reminder, x minus 1 is a vertical asymptote at 1. The parent function it looks like this. It's showing here on top right. So it just kind of goes like that, where it comes down like this. So the region from 3 to 4 is something like this over here. Okay. When they give you the bounds, those are the bounds of the integral.
Okay.
And then it's the function with the dx here.
Okay.
All right, so the antiderivative of this, this is a U substitution problem, but maybe you're okay with me just writing this as the antiderivative. Do you want me to show you the U substitution for that, or is it okay like this?
Yeah.
All right. All right. So you just evaluate the bounds. So it's the natural log of 3. 4 minus 1 is 3, minus the natural log of 3 minus 1, which is 2. And then, I mean, if your instructor is really difficult, you could combine these into one logarithm.
Yeah. Okay.
Any questions on that or any concerns?
The natural log of 2, it would be, okay. So 4 minus 1 and 3 minus 1. Okay, I didn't.
Yeah, sorry. Yeah, it just.
No, you're good. I just, when I saw the 3, I immediately was like, oh, we took 3 and 4, but then I saw 2 and I was like, wait. But that makes sense. Okay.
Yeah. All right, fantastic. So the next one here is a little harder to sketch, although it's not impossible. It's just you can't get a super accurate graph. Your parent function is x cubed.
Okay.
And x cubes come up, go, and they look like this. So the 4 stretches it, the 2 moves it up. Because you're from 1 to 2, you're kind of only care about the first quadrant of this anyway. So like what I would do is realize, okay, it's there, and this is where it kind of snakes. So you know, if you can imagine, like it's coming up and then does that, and this is where it's like, okay, well, it does that, something like that, not to scale, and then we go from 1 to 2, and it's this region in here. So I guess in short here, make sure you know your parent functions really well, because they're probably looking to see, like, does it have the right curvature roughly?
Yeah.
They give you the bounds here. So it's from 1 to 2, 4x cubed plus 2 dx. This is a power rule antiderivative. So that's x to the 4th plus 2x evaluated from 1 to 2. So we get 2 to the 4th plus 2 times 2 minus 1 to the 4th plus 2 times 1. And that 2 to the 4th is 16 plus 4 minus 1 plus 2. Looks like 17 is your final answer.
Okay.
All right, so the next question here, C, gets a little more interesting because they don't give you the bounds this time. And so you do have to graph, but you could start out by just setting them equal to each other. You will have to do this eventually. Okay. And as a reminder, when you're solving, you move things to one side. You don't just divide them because you'll miss one of the solutions. So then you factor out x from both. You set them each equal to 0. And when you only have 2 bounds like this, that is your, or I'm sorry, 2 intersection points, that is your upper and lower bound. There are problems where you get 3 intersection points or more, and then you do something different, but this one is not the case. So the sketch here, and you know, probably you know what these look like, but it's like, well, which is above, which is below? The way that you actually can do it without graphing, although I know you do need to graph, is you choose an x value between the limits.
Gotcha.
So like x equals 1/2. And in the first case, it's y equals 1/2 squared, which is 1/4. And in the second case, it's y equals 1/2, which is higher or which is bigger, 1/2 or 1/4. It is 1/2.
Mhm.
So what that tells you is this is actually the top function. And
Okay.
this is the bottom function. Because if you choose the wrong top and bottom, you will get the negative of the correct answer.
Okay.
Does that make sense?
Yeah.
If you undo them. So try not to do that. Try to pick this correctly. Just for scale here, I'm going to call this 1 and this 1. So y equals x looks like that. Then x squared actually dips kind of underneath that. So you get this sort of region here like that.
Okay.
So you're integrating from 0 to 1, x minus x squared, top minus bottom dx.
Mhm.
So you get 1/2 x squared minus 1/3 x cubed from 0 to 1. Evaluate at the top and the bottom endpoint. So whenever you're evaluating a polynomial at 0 like this, you don't have to actually evaluate it. It's 1/2 1 squared because it's 0.
Mhm.
Yeah, 0 minus 0 if you have to show your work. 1/2 minus 1/3, that equals 1/6.
Okay. Gotcha.
Okay, D,
Mhm.
letter D. This is calculator okay.
Yeah.
So when you're given the X bounds, you could almost give this someone who has no idea what calculus is and just say, put them here and here, put the function here.
Okay.
And then you integrate. So you're going to use that math 9 FN int, I think, on yours. If you got a calculator handy, please try to do this. The mode is important here. The mode should be in radians. If you're taking another math class or physics class, you may find that you've got it in the wrong mode potentially.
Mhm.
Just keep that in mind.
Yeah. Okay. So mode in radians. Yeah, radians. Okay. And then FNIP. Gotcha. Sorry, what button would I push on my calculator? How would I get that on my calculator?
It's the math 9 on there. I can also show it on my screen.
Oh, okay, got it.
And I think it's called FN int.
Okay. Yeah. Okay. And I just plug all the numbers in.
Yes, I would recommend trying at least one to make sure you're comfortable with this in case you have exactly this on the test where you can just plug it in and go.
Yeah. Okay. 1 plus natural log cosine. It's not letting me cube cosine. It's fine. Not cube. EX. Okay. Okay, got it.
And hopefully you got really close to that answer.
Yeah.
Okay. All right, so that takes us out of the area and then moves to volumes. The next problem is an ellipse Does it say that? Yeah, it does say that.
Mhm.
So you can't, so you can't actually graph this with the TI-83. To graph it, you would have to solve for y, and you'd end up getting y equals 9 minus x squared divided by 9 square root. And then to get both the top and the bottom, you would have to do the negative of it. Because you take the square root, you get plus or minus. You can obviously simplify this, but here's what it looks like. Okay. So you can actually, you could choose to revolve this thing, but I actually think it's better just to revolve the top half there. And that's kind of more consistent with what you're going to see in other problems. You get the same shape. I guess maybe that's what I'm trying to say. So when you revolve just the top half, you get the same three-dimensional figure as revolving the whole thing.
Yeah.
Okay. Hopefully you believe me. If you don't, I mean, we're gonna have to go with it for the moment here, because this is the more common problem. So this is that y equals square root 9 minus x squared over 9, which if you divide both of these, it's square root 1 minus and then it's x squared over 9, so you can write that as x over 3 squared, like that. Okay, and that's, or we can leave it as square root 1 minus x squared over 9. We'll see what we need coming up. So this is a disk problem. It's a disk problem because you're revolving around the x-axis and there is no space, there's no gap. You're on the, the sideline. There's nothing between you and being out of bounds, okay? So the disk problems are all the same. You integrate pi r squared dx and a to b. So in this problem, your a is the lower bound, -3. Your b is the upper bound, 3. Better to bring that pi out. R right here, maybe this is confusing, but r is really a function of x, which means it's your y. It's the height.
Okay.
And your y is, pick one that you like. We'll go with actually this last one here, 1 minus x squared over 9, but then you square it.
Okay.
And then the squaring, it's important because that's the only way you can actually do this particular problem, because without it, you would run into issues to do that.
Gotcha.
Okay.
Okay.
So now from here, it's pi integral -3 to 3, 1 minus x squared. I'll put that 1/9 in front, dx. So now you just find your antiderivative. So it's x minus x cubed 1 over 27 times pi, evaluated from -3 to 3. And it said calculator was okay, so I shouldn't even have done this. We should have just stopped here
Gotcha.
and use your calculator.
Put it in.
All right, next one, we'll go with number 5. Here, do you know if your instructor wants you to graph these?
I don't think it's necessary. I think if we did, he would say.
Okay, so the reason I ask is this one gives you the x limits. So you can just go 0 pi over 3. You don't have to, if you did need to graph it, you'd want to just verify that this was good, but it just gives it to you there. So secant of x, because there's no gap, and maybe, I don't know how to tell you like how you would know that there is no gap between secant and the x-axis, other than to say when there's only one function, there is no gap. So if you only get a secant and like a y equals 0, or just a secant, or just a function, it's always a disk problem. It's generally when you have two functions that you get a washer.
Mm-hmm.
Okay, so the setup here is pi r squared. Your r is the secant. squared dx like this.
Okay.
All right, so this one, the antiderivative of secant squared. Do you recall that one?
Secant squared. Oh my God.
Or the derivative of what gets you to secant squared?
Yeah.
So it ends up being just tangent.
Okay.
If you have time, definitely would recommend looking at.
I get secant confused with sine, and I want to say cosine. Think about it for a second.
Yeah. I will admit some of this doesn't make any sense. Like if you're not really in tune with like looking at the stuff every day, there is no like logical way to remember this other than to just go in and look at it again.
Sorry, quick question. When it asks for like a volume and it's rotating or revolving or something, is there always the pi in front?
Yes, but there's really only three methods you've learned. One is cross sections. The next one is disk, and one is washer, or the other one is washer or ring. These always have a pi. The cross section, if it's a circle, it has a pi, but the cross sections could be triangles. They could be squares.
Okay.
They could be trapezoids in some weird scenario. Sorry if that didn't answer it directly, but like disk and washers are always going to have a pi.
Okay. Gotcha.
So you have evaluate the two endpoints. So again, kind of a unit circle potential, problem here. You got where's pi over 3? It's the one up here. You can see that the x is like halfway, so it's 1/2. The y is closer to the 1, and then tangent is y over x, square root of 3 over 2 over 1/2. Tangent of 0, 0, 0 over 1. So it ends up being pi square root of 3 as your final on that one.
Okay.
Do you have some other questions? I guess more conceptual questions that you would like me to answer like this?
Can you explain again, like for 5, how you got the equation from what it told you, like the pi evaluated from 0 to pi over 3?
So the limits, when there's only two limits, and that's a shortcut, I'm telling you, you just put the limits in
Okay.
as your upper and lower bound. To answer that other part, do you recall how to graph secant? And if you're not sure, I will just explain it, because that's also important.
Yeah.
So secant comes from cosine. Cosine starts high, goes low, comes up like that, and then secant is the reciprocal. So you need these kind of places where it hits like that, and then it's the u thing above it that hits. So notice that there is from 0 to pi over 3, which is somewhere. I hate when I do this because it gets jammed up in here.
Yeah.
But there's I call it no gap. There's no gap between the revolving axis.
Okay.
And like an end line in a sporting event, a sport that you play.
Yeah.
That's out of bounds. You just can't go across. So there's no gap. There's no like, if you're studying history, there's no demilitarized zone between two countries. It's like that when it goes all the way, that's how you know it's a disk. It's also a disk because there's one function. They're only giving you one function.
Yeah.
And you're going to see maybe in the next one that there are two functions. I don't know what the next one is.
Okay. Yeah. Okay.
Is it clear? Because 7, which is this kind of this R and S, maybe will clarify that because it's a washer, I believe.
Okay. Why do you square secant x?
Okay, so the reason you square it, and I should have done over here. There for a disk, it's pi r squared.
Okay.
And for a washer, it's
that's what I thought.
R squared minus R squared. Yeah.
Okay.
And if they give you a function that's already squared, you still have to square it again.
Okay. Yeah. Okay. Yeah, that makes sense. Answered my question.
Perfect. If you need to interrupt me, please do. All right.
Sounds
6. All right, the region enclosed by the graph of y equals x squared, x equals 2, and the x-axis. So this one's not too bad to graph.
Okay.
X squared, you get at that point 1, 1, and then 2, 4. So it's this is your x squared, this is your 2, and here's your x-axis. So it's this region right here. Okay, but this time we're going around the y-axis, which changes everything.
No.
Yeah. So x-axis, and this applies to area and volumes. It's top minus bottom.
Okay.
Y-axis, which is what we care about now, is right minus left.
Okay.
So your right function is x equals 2. Your left function is y equals x squared. But when you're doing a y-axis integral, you have to solve for x. And in most x-axis integrals, it's already solved for y,
Okay.
which we saw in the previous examples. So it, like, you don't think that that's a step, but it is. So when you solve for x here, you get x equals positive square root of y and x equals minus square root of y. And you're like, well, how do I know which one it is? Well, it depends. It depends on where we are. So see, all these y's are positive. So it's this one.
Okay, that's what I thought.
Okay, but because you're squaring it, you can also get away with using the wrong one.
Sure.
You know. So this is a washer problem. It's a washer problem because there is a gap between the region that you have found, the red. There's a gap between the red region and the axis you're revolving around.
Okay.
And I don't know if that's the right word. It's a word I've been using a lot lately. If you have a better one, please let me know. However you want to remember it there. So the washer, you need your big R. And so they're always from the axis that you're revolving around to the in this case, the rightmost function, that's big R. So big R is 2.
Okay.
Little r is the other one, the closer one. So little r and your problem is square root of y.
Okay.
Your integral is pi big R squared minus little r squared dy. It could be dx if you're going in the x direction, but the r's represent the function. So for you, it's 2 squared minus square root of y squared dy. And then your bounds, this is where it's awkward. It's easy to put the wrong bounds. You want the bounds are along the y, not the x. Okay. So it goes from 0 to 4 because that's the place there. Okay, so this is 4 minus y. So our antiderivative is 4y minus 1/2 y squared times pi. Bring down the limits of integration. 4 times 4 minus 1/2 times 4 squared minus 0 times pi. You get 16 minus 8, you get 8 pi after all that.
Okay. How'd you get the limits again?
Limits come from because you're revolving around the y-axis, you go to like wherever it hits them on the kind of, it becomes, and this is maybe unclear, it's top minus bottom on the limits. I'm sorry.
Okay, sorry, it just clicked.
Okay, because the last problems, they just gave them to you and it wasn't as like compelling, but if we like see how the limits are actually on the x-axis here, and because it was an x-axis integral, that's why we went from -3 to 3 here.
Gotcha. So it would be where, what's it called? So where the two lines meet.
Yeah, you need that intersection point, but, and I guess I didn't cover that because I made the graph pretty accurate, but you
Mhm.
get the intersection point from plugging 2 into x squared and getting y.
Got you. Okay. Okay. Calculator. Okay.
Any follow-up to this?
No, that was my only question.
Okay.
I got it.
All right, so next question. It says, let R be the region bounded by the graph of y equals e to the 2x minus x squared. So that's this kind of normal distribution looking thing. Horizontal line y equals 2. So R is this region up here. S is the region below it. It's the region bounded by the graph, but between the lines 1 and 2. Okay. So part A is to find R, and that says calculator is okay. I believe it said that, yeah, because you can't do this without a calculator. You need to find these intersection points. And so by hand, okay, you're like, all right, well, I can do this by hand, right? I'm a pretty good math student. 2 equals e to the 2x minus x squared. You got to take a natural log of both sides. Then you got to use quadratic formula, and you won't get it. You won't get it. So how comfortable are you? You know, y1 is 2, y2 is e to the 2x minus x squared. Do you think you can, in a short amount of time, find the two intersection points? And do you need any help figuring that out?
I might have forgotten how to do that.
All right, so let me pull up the calculator and I will show you.
Okay.
This won't take very long, but this is the necessary skill for doing well with this type of question. All right, so y equals, we'll go 2, and then we'll go e second e 2x minus x squared. Shortcut here, don't graph, zoom. And if you've already done a graph, go do a zoom standard.
Mhm.
Sorry, zoom standard's a 6, and then graph it. And if you still don't get what you want, like this one worked out fine, but if it doesn't give you what you want, you can do a zoom fit on it. So actually, I'm going to try modifying the window here. So they kind of give it to you in the problem. Like x goes from, we'll go -2 to 4. And then y, we're going to go from, say, -1 to 3. And that will just help us to see it fit the window better rather than this. So the part you asked about that, I think is really important is you got to go hit second calc, and then you want the intersection. So the way the algorithm works is it wants you to pick the first curve, and it doesn't matter which one is the first curve, but you choose the first curve. So I'm going to hit enter. It will jump you to the second curve. You do not have to be near that point where they intersect, just in the neighborhood. Enter, and then you always guess at the same point, enter again. And there you go, it gives you that first intersection, 0.446. To
Okay.
find the other one, you can use second calc, intersect again. Do not use trace. It will not work very well. So you got to get over kind of in the vicinity. But you don't need to be right on it. I think that's students try to get right on. You can just be close.
Where's calc? Second calc.
It's under trace.
Oh, I didn't even see that. Okay.
Yes. So I'm going to label those here 1.554. Okay.
Okay. Okay.
Would you like me to go over anything again on the calculator before I jump back to the other
No,
screen?
got it on the
Okay.
calculator.
Okay. So we're back to the other screen. we want the area R. R is a top minus bottom, okay? And your left bound is, those are the numbers we just found. It's the 0.446 to the 1.554. And because it's an area, it's just top minus bottom. You're not doing pies, you're not doing volume. Your top is the E to the 2x minus x squared minus 2. And this is a calculator. There's no way to do it without doing the calculator.
Okay.
Let me get you a number for that.
Plug it into.
So what I get is 0.514143, roughly.
Okay. I get minus 2 dx 0. Yep, got that.
Fantastic. So to find S, I'm going to go back to the original image, and I'm going to just snip it again.
Okay.
This is the kind of problem where your instructor may even say like set up, but do not calculate. Okay, so here's S. So S right here, do you see that? If you're kind of in this, let me draw it here. If you're in this part in red, kind of this region here, do you see that the top is that curve and the bottom is the line y equals 1?
Mm-hmm.
But once you get to here, between the two, let me draw that in a different color, blue, your top is the 2 and your bottom is the 1.
Mm-hmm.
And then when you get over into this third region, the top is that function again, and the bottom is the line y equals 1. So it's actually 3 regions.
Yeah.
Okay. So the way you would calculate each of these, I'll color code it here, is the first one is the integral from 0 to this place right here, which we found in the previous problem. It's the 0.44, already forgotten it.
446.
6. Okay. And your top is E to the, what is it, 2x?
Minus x.
Yeah, 2x minus x squared minus 1, not 2, because the 1 is the bottom.
Okay.
Dx.
Gotcha.
Plus, okay, now to do this middle one, do you agree that this is just a rectangle?
Yeah.
You could integrate it. So let's say your instructor really wanted an integral, which is really weird, but you could. The integral would go from 0.446 to 1.554. Your top is 2, your bottom is 1. There's that part.
Okay.
Or you could just do base times height. The base is the difference in the x values, the height is 1, which is what this gives you.
Yeah.
Plus the integral from 1.554 to 2.
Okay.
And actually, yeah, yes. And it would be the E to the 2x minus x squared minus 1. Although I guess I'm making an assumption that we should actually find this point. It probably isn't 2.
It is.
Is it?
Yeah,
Okay.
I went to it on the calculator.
All right. Boy, I was about to be shown up there because it might not be, but okay, but it is.
They could trick you with that, so
Yeah,
it's good to check.
yeah. And this is, you said not to do AP questions. This probably is, but it's kind of still in the realm of like what's reasonable to do.
Yeah. Like it's not too out of the box.
Yeah.
Oh, it's raining.
Any questions on that?
Yeah, and then I just plug that all into calculator.
Yes, separately, get the three numbers, add them together.
Perfect. Yeah.
You could be asked, let's say, or let's say I wanted Q down here, it would be the same thing, except you'd have, you know, different limits
Mm-hmm.
like that. All right, so the next page that I see, it says a particle P. This is like for sure an AP question. Would you like us to go through it or move on to something else?
We can move on to something else.
Okay. 3.
We
Also,
did C in class.
say that one more time.
So let's do A and C because
Just A and C. Okay.
that would probably be important if we did it in class.
Yeah, I don't know why you wouldn't do A first, but it's not for me to.
People were asking questions, and someone asked specifically B.
Okay.
Of this one, I think. Can't remember.
All right. God, this question is really antiquated. I mean, spinning toys. I mean, I don't think anybody's making those anymore.
Yeah.
We'll see. So they say, here's your function, and they're saying, here's the graph of the function. And they want, so this point right here does not depend on the value of C because you're setting CX square root 4 minus X squared equal to 0. So when you solve this, you set CX equal to 0, which means X equals 0, no matter the value of C. That's the one on the left here. When you set the other one equal to 0, it's just the inside part that has to be 0. So X equals plus or minus 2. So that tells you that this is always 2. Doesn't matter what C is. That's always 2. And that's critical.
Okay.
Because in the first problem, it actually wants you to find the area of the region. But you need the two bounds. Okay. So area is not a disk. It's not a wash, just an area. So you're integrating from 0 to 2. And it kind of is a top minus bottom, but your top is the Y equals this thing, but your bottom is 0. So you don't have to put it in like that. So whenever you're just given one function, that's what you're integrating. 6x square root 4 minus X squared dx.
Okay. How do you get 6 again? Oh, wait.
It's given.
It's given. Okay. Didn't see that for a sec. 6x. Okay.
All right. Now, this is a problem you would have seen in the last chapter. So like now it has nothing to do with the problem up above. This is a U substitution problem. What do you think your U is here?
Square root of 4 minus X squared.
So without the square root, it is the U, because when you do that, you take a derivative. You would see that you don't cancel everything when you do that. So your du is minus 2x dx. Solve for dx. Dx is du over minus 2x. Okay, and I would change the limits of integration here. I would put 0 into this, which is 4, and 2 in, which is 0. 4 minus 2 squared is 0. Because if you're going to go to the trouble of changing from X to U, you might as well do it with the new limits.
Yeah.
Okay. And unfortunately, it's a little odd because it is 4 to 0 now, even though you're used to seeing 0 on the bottom. This is okay. It does work out in the end. 6x square root of U dx is du over minus 2x. Stop moving that around. Make sure you're okay with this line.
Okay. Got it. Yeah.
All right. So from here, you can see that the x's cancel. 6 divided by -2 is -3. I'm going to put that on the outside. Integral 4 to 0, u to the 1/2 power du. Right. So if you wanted, you could change the negative here to a positive and flip the bounds.
Okay.
Would you do that? Because I want to know which way to go here. You get the same answer, but which way should we go?
Probably I'd go that way. I like positives, so.
You like this. Okay. So this gives you u to the 3/2, 2/3. Okay. 3 comes down. Evaluated from 0 to 4. So this becomes 2 times 4 to the 3/2 power minus, because 3 times the 2/3 gives you the 2. So you're just evaluating this u to the 3/2 minus 0 to the 3/2 power. This is 2 squared. 4 is 2 squared to the 3/2 power. So the 2 times 3/2, the 2's cancel, just 3. 2 to the 3rd is 8 times 2 is 16. So you end up getting 16 times the 3, which is 48.
When does 2 come out, and where does that?
Oh, no, I'm sorry. That does not, it's not times 3.
Oh, it's times.
The 3 times 2/3, this gets you to the 2.
Okay.
So it's 2 times 8, it's just the 16.
Okay.
This would be a good one to work out on your own. Maybe just starting back from here, just making sure you're good with it.
Okay.
See if you like it, like steps.
Yeah.
All right, so, and should we do part C?
Yeah.
All right, so it says for another spinning toy, the volume is 2 pi. Let me go back and grab the image, and then let me also look at this, and then I think it says around the x-axis for part something.
Yeah.
Yeah, x-axis, so around this right here. Okay, so the volume, is this, first of all, is this a disc or is it a washer?
Goes around the x.
So one answer to it is there only, if there's only one function, it's a disc.
Yeah, disc.
Another answer is if there's no gap between this. So there's a lot of lines here. Like I would not want to not want all these lines here, but that's your R.
Yeah.
So your R is CX square root 4 minus X squared, like that. So for a disk problem, you're integrating from 0 to 2. This is always 2. We talked about the last problem. Pi, and then it's R squared. So it's CX square root 4 minus X squared all squared dx.
Okay.
Before I go any further, is the setup okay? Like, is it understandable? All right.
Yeah.
So from here, you do have to square stuff. So it's C squared X squared. The square root is undone by the square here, so you get 4 minus X squared. So because you're integrating this, I would bring the C squared out because it's a constant pi C squared integral 0 to 2, and then you should distribute in because you have to find the antiderivative of nice things, and products are not nice things. So now your antiderivative is 4/3 x cubed minus 1/5 x to the 5th evaluated from 0 to 2. So you have this pi C squared coming along the whole time. 4/3 2 cubed minus 1/5 2 to the 5th, and then minus 0 because those go away.
Yeah.
So from here you get 2 cubed is 8, so that's 32 over 3. 2 to the 5th is 32, so minus 32 over 5. Okay, and you may have lost track what we're trying to do, but if you go back to the original, or if you look on your paper, it says the volume is 2 pi. Like, they're giving you the answer.
Yeah.
The answer is 2 pi, and you need to solve for C. So first we'll start by combining these. We'll make a common denominator here, 15.
Okay.
So multiply this by 5 is 160. Multiply this by 3, it's 96. Pi C squared is 2 pi. So this part inside here is 64 over 15. pi c squared equals 2 pi. Okay, the pi's cancel. Just divide them out. You multiply by the reciprocals, you get c squared equals 30 over 64. And then square root of both sides. So c equals, you might think it's plus or minus, but I think it's that c is always positive somewhere. Yeah, it says that. So it's just plus
Okay.
64. So if you can get this far, I mean, the rest of this is not anything to do with calculus, but 30 is just the square root of 30 over 8.
Okay. Got it.
Let me see what else we can do relatively quickly. Oh, is that all, that it may be all you sent?
Yeah, I have 4 more pages, but I scheduled 2 more appointments for Thursday and
Oh, perfect. Yeah,
Sunday.
if
So
you're
let's finish it.
if you're okay with that, we can just finish
Yeah,
it then.
yeah, I'm good being done a little bit early.
All right. Thank you so much for scheduling. I'll see you. I think you said tomorrow or
Okay.
Thursday or something. So
See you
cool.
then. Thank
Have a-
you.
Bye now.